Okay, the third topic in section 1.2 is the idea of restricted domains for a function. We use restricted domains when the behavior we're modeling is only true for certain values of x. Here's an example. The height of a growing child between ages 3 and 10, where x is in years and y is in inches, can be modeled by the function y equals 3x plus 26 for the values of x between 3 and 10 inclusive. Now, if we were going to graph that, the graph would look something like this, where we see a line only for the values of x between 3 and 10. To be able to do this in our TI-84, we're going to take advantage of what's known as a Boolean variable. A Boolean variable has two values, 1 or 0. And those two values occur when the condition that's being used for the Boolean variable is true or false. So if the condition is true, then the Boolean variable has a value of 1. And if the condition is false, the Boolean variable has a value of 0. For example, for the Boolean variable, our condition, x is between 3 and 10 inclusive, if we let x equal 7, the Boolean variable is true and equals 1. If x equals 2 or 15, values outside of the condition, then the Boolean variable equals 0. We're going to use these in our TI-84 to restrict the domain of our function 3x plus 26. So we'll start by going in and entering the function 3x plus 26. We're going to put it in parentheses, and then we're going to divide by this Boolean variable. To divide by this variable, we need to go into the test menu. So we'll start with the parentheses, and we'll say 3. Now we need the condition less than or equal to. We find that in the test menu, which is second math. There it is at number 6. 3 is less than or equal to x. Then we need the second condition. We can't use a compound inequality. The calculator doesn't recognize compound inequalities, so we need two conditions. The first being 3 less than or equal to x, and the second one being x less than or equal to 10. We join these two by an and. We also find that in the test menu, second math, and we go over to logic, and we find the and condition, and then we need x, and we'll go back in, get that less than or equal to sign again, 10, and close off the parentheses. So what we've done is divide by this condition. When the condition is true, we're dividing by 1, so we see the graph. And when the condition is false, we're dividing by 0, so we don't get a value. And that's why we get a graph that covers the values between 3 and 10. Now I chose my window to cover the years between 3 and 10 and the values of y that would be produced within that range. So let's take a look at the graph again. Pull it over, and there we have it. Now we'd also like to be able to reproduce this graph in other types of software, like WinPlot, and we could do that. We'd like something that looks like this. And in WinPlot, it's actually even easier to recreate the graph. We'll call up WinPlot. We'll use the two-dimensional screen. We're going to reset the window, view, set the corners, so it matches the window that we used in our calculator. Let's see, minus 10 and 100. We'll apply. That looks good. Now we'll enter our equation, which was an explicit equation. The equation was 3x plus 26. Now here's the easy part. We want to lock the interval. Which values of x do we want to see this equation for? The low would be 3, and the high would be 10. I always like to make it a little thicker, and let's make it blue. There we go. And say OK. And we get our restricted domain graph.